Yes, dear children, let us see today miscellaneous reactions. We have seen nucleophilic addition followed by elimination, then we saw reduction, oxidation, and now we are going to see certain miscellaneous reactions. And the first one here is aldol condensation. Okay. Now in this aldol condensation, the name aldol is telling you that in the product there is an aldehyde group as well as an alcohol group. That is called as an aldol. A compound containing both alcoholic group as well as aldehyde group is called as an aldol. Now in this, two molecules of aldehyde, they react in the presence of dilute alkali to give you an aldol. Now look here, OH is there, CHO is there. So this is called as an aldol. Okay. Now what are the conditions for a molecule to undergo this aldol condensation? The molecule should possess an alpha hydrogen and the reaction should take place in the presence of dilute alkali. Okay. Now, what is alpha hydrogen? Alpha hydrogen is nothing but the hydrogen adjacent, the hydrogen that is attached to carbon adjacent to the functional carbon. So this is your functional group and the carbon attached to the functional group is called as alpha carbon. This is called as alpha carbon. Okay. And the hydrogen attached to alpha carbon is called as alpha hydrogen. Now, why alpha hydrogen? Because alpha hydrogen is more acidic. Okay. Now, how it is more acidic or why it is more acidic? Now, let us see the mechanism of the reaction. You will understand. Now, what happens in the first step? I told you this is taking place in the presence of dilute OH minus, and this OH minus, what it strikes the acidic hydrogen. I told you the hydrogen attached to alpha carbon will behave as an acidic hydrogen. Okay. Now why it is an acidic hydrogen? Because this carbon is attached to an electron withdrawing carbonyl group. Because of the electronegative oxygen, the bond pair will be pulled towards oxygen. So this will get a positive charge, right? So this CH can easily ionize because this bond can go over there, right? And leave this as H plus. Okay. So this H plus is moving along with OH minus as water. Now what are you left with now? This bond is shifting as charge on carbon. Okay. This is the charge on carbon. And so you have CH2, then C double bond OH. Now that condition, there is electron rearrangement taking place. This negative charge is shifting towards CC bond, okay, and it is becoming a double bond. And when this is shifting, automatically this bond will shift as charge towards oxygen. So what you have CH2. This electron pair has come here as a bond, so you have a double bond here. And this is shifting towards oxygen, so you're having a negative charge on oxygen along with that hydrogen, okay. So this is the resonance stabilized enolate ion. Why you're calling it as enolate? En means double bond, okay, and this O is having O minus, exactly, that is why you're calling it as enol. अगर OH होता तो all है, double bond है तो en है, तो enol होने वाला है, enol. That is why you're calling it as enolate ion, okay. Now once this enolate ion is formed, now this under resonance stabilization, is it not? So here this is going to attack another molecule of aldehyde. What is this? This is a carbanion. Okay. Negative charge on carbon is called as carbanion. So it is acting as a nucleophile basically. This negative charge is attacking the carbonyl carbon such that this is shifting. So this is an electrophilic carbon, is it not? So the negative charge is hitting this electrophilic carbon and this becomes O minus.